All right, so for 12.3, the only parts we're actually going to be able to get to today are the determinant of a 2 by 2 matrix and the inverse of a 2 by 2 matrix. So first, we need to start off with a definition of determinant. Okay, so a determinant is a value assigned to a square matrix, which means if you've got a 2 by 2 or a 3 by 3 or an 8 by 8 matrix, they all have determinants. If it's not square, there is no determinant for it. So what we're going to learn today is just how to find the determinant of a 2 by 2. So first thing is about the notation. Sometimes they will just write DET in front of a matrix to tell you that you're supposed to find the determinant. Sometimes they will just use these symbols, which look like giant absolute value symbols, and you're supposed to know that that means determinant. Depending on which book I've taught out of, I've seen it both ways. Okay, so I don't care which way you write it. Your current book uses DET in front of the matrix. So now, to find the value of the determinant, all you're going to do in your matrix is you're going to start out multiplying this diagonal together, and then you're going to put a minus sign, and you're going to multiply this diagonal together. That's the formula that's here in my little circle. One diagonal minus the other diagonal. All right, so let's go ahead down here to this example where we're actually going to find the value of a determinant, and then I'll show you what we use a determinant for. So for problem 2, they want me to find the value of the determinant for this matrix. I'm going to start out by multiplying these two numbers on this diagonal together. So it's 3 times 5 minus. It doesn't matter if you do 3 times 5 or 5 times 3. Then you multiply the ones on the other diagonal together. So that's 2 times negative 1.
You always subtract?
Always. Yes, always subtract. So you get 15 plus 2 is 17. That is the value of the determinant. Okay? That's a pretty easy formula. 2 by 2s are not bad at all. Now 3 by 3s are more complicated. We are not going to get to that. No. Nope. So now we're going to take that determinant and we're going to find an inverse of a matrix. Okay, you know how when we were solving those basic matrix equations and I said you can't divide by anything, you multiply by a reciprocal? Well, if we were able to get to the systems of equations part, you would need to do like the reciprocal of a... Okay, go ahead. We would need to do the reciprocal of a matrix. Well, there is no such thing. So it's really the inverse. So that's what we're going to do here. We're going to find the inverse of a matrix. So here's what I want you to see. In this bubble here, the way we find an inverse is we're going to put 1 over the determinant, and then we're going to rearrange things inside that matrix. You see the A and the D swapped places? And then the B and the C stayed where they were. We just changed the sign. We made them negative. So I want to do that for this problem. If I'm going to find the inverse, I put 1 over the determinant, which was 17. And now this 3 and 5 are going to swap places. The -1 and 2 are going to stay where they are, but I change their signs. So the -1 becomes positive, the 2 becomes negative. And then I just use scalar multiplication. I'm going to multiply everything inside by 117. So I get 5 over 17, 1 over 17, -2 over 17, and 3 over 17. This is the inverse.
Where did we get the 17 from? Just the original?
No, that was my determinant here. You remember we did it just a second? We're going to put 1 over that determinant. So yeah. All right, I've got 2 more examples. One we're going to do together, and the next one I'm going to let you work on it, and then we'll talk about it because it's a little bit different. Anybody still copying or checking here? All right, here, I want to find the inverse of matrix A. So the very first thing I'm going to do is find the determinant. So what do I multiply together first? -3 times 3. Minus, what do I multiply together now? -1 and 6. So that's going to give me -9 plus 6. My determinant is -3. Well, -6 times -1 gives me a +6. Yeah, be careful with your signs. So now that we're done with that, I'm actually going to find the inverse. Remember, your inverse is 1 over that determinant. So I start out with 1 over -3. And now I want to rearrange things in my matrix. So this -3 and +3 swap places. My 6 and -1 stay where they are, but I change the signs. So that's going to be a -6 and a +1. Use your scalar multiplication. -1/3 times 3 gives me -1. -1/3 times -6 gives me a +2. On the bottom row, I'm going to get -1/3 and +1. This is the inverse of that original matrix. Yeah.
So you didn't switch -6 and 1, but in the previous example, you switched the 2 and the -1 and then changed the sign.
Yeah, no, I left those where they were and changed them. Yeah, that's okay. All right, questions on this one? All right, last problem. I want you to see if you can find the inverse of this. And like I said, something a little bit different happens with it. Okay, so I'm going to freeze this projector screen up there. and I'm going to start working it here while you work it, and then we'll talk about them. So when you finish, check it up front with mine, and then we got to talk about what that means.
You don't solve it anymore.
Well, here's the thing. What is it when you've got a 0 on the bottom of a fraction? It's undefined. Can you multiply undefined by anything? No. So here's the thing. If your determinant is 0, you can't do anything to find the inverse. It has no inverse. Okay, whenever your determinant is 0, there is no inverse. It's not a no solution, because we weren't trying to solve for anything. We were just trying to find the inverse, and there's not one. So that's it.